He asked, how comes it that human beings whose contacts with the world are brief and personal, are limited, are nevertheless able to know as much as they do know? And the roots of that go back to Plato. We can borrow some of the same words to formulate Orwell's complementary problem. How comes it that human beings with ample and reliable information at hand and nevertheless know and understand so little? Descartes' problem had to do with freedom of choice and action, unique to humans, so he argued, and what he called the noblest thing we have, illustrated most clearly for Descartes and his followers in what we may call the creative use of language, the capacities shared by all humans to freely express their thoughts in constantly novel ways over an infinite range, in a manner that's appropriate to circumstances but not caused by them. That's a crucial distinction, and that is also not causally determined by any extramental internal state. Humans may be incited or inclined to speak in certain ways by internal or external circumstances, but they are not compelled to do so, as his followers put the matter. For them, the dividing line between humans and what they called beast machines, animals or machines. They were describing the normal, everyday use of language. Later, Wilhelm von Humboldt called it the infinite use of finite means, a core element of the human creative impulse that should be nurtured by education in any decent society. He and other classical liberals argued. These are ideas that were developed further in Marx's early manuscripts and that have repeatedly animated popular movements. I discussed these three problems in memorial lectures for Bertrand Russell at Cambridge University 40 years ago. About Plato's problem, a good deal has been learned since, at least in a few domains. Plato, of course, had an answer to the problem, his theory of reminiscence from an earlier existence. Leibniz found Plato's thesis convincing when, as he put it, purged of the error of reminiscence, which to us must mean, when formulated in terms of genetic endowment, a topical that's at least in principle susceptible to study. Descartes' problem remains shrouded in mystery, perhaps permanent mystery, so Descartes conjectured, and we have no strong reason to believe otherwise. David Hume reached similar conclusions about the limits of human understanding. He was writing about the man he described as the greatest and rarest genius that ever arose for the ornament and instruction of the species, Isaac Newton. And about him, Hume concluded that his most memorable achievement was to draw the veil from some of the mysteries of nature, while at the same time restoring nature's ultimate secrets to that obscurity in which they ever did and ever will remain. Presumably it was with such thoughts in mind that Russell gave his last great philosophical work, from which I quoted, the title Human Knowledge, Its Scope and Limits. The title is appropriate if humans are part of the organic world, not angels, so that all human capacities have fixed scope and limits, the two intimately related. The inherent properties that provide their scope also determine their limits and inescapable contingency. That's true whether we're considering athletic feats, intellectual and artistic achievements, or any other capacity, including the most ordinary and familiar, such as speaking our language. Newton had consigned nature's mysteries to permanent obscurity, Hume explained, by revealing the imperfections of the mechanical philosophy. Philosophy then, of course, meant science, so mechanical science. That's the conception of the world as a machine. That conception provided the criterion of intelligibility for Galileo and, in fact, all of early modern science, including Newton, who regarded his demolition of mechanical science as so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it, though he was compelled to accept that it is true, which was inconceivable to him, but nevertheless true. So by invoking the inconceivable notion of action at a distance, we concede that we do not understand the phenomena of the material world, where understanding is given a sharp meaning. It's construed in terms of intelligibility to the human mind with its own limits. The great scientists of the day shared Newton's judgment, sometimes with a degree of contempt. Christian Huygens, for example, described Newton's principle of attraction as an absurdity. Leibniz argued that Newton was reintroducing occult ideas similar to the sympathies and antipathies of the much ridiculed scholastic science, and that he was offering no physical explanations for phenomena of the material world. To these objections, Newton partially agreed, but only partially. His principles, he conceded, were occult, but not occult in the sense of the scholastics. The reason is that, as he put it, while the causes he postulated are occult, nevertheless, to derive general principles inductively from phenomena, and afterwards to tell us how the properties of actions of all corporeal things follow from these manifest principles, would be a very great step in philosophy, even though the causes of these principles were not yet discovered, because he hoped they might be discovered. But in fact, they never would be discovered in terms that Newton and other founders of modern science regarded as intelligible in accord with common sense understanding. So in that respect, Hume's statement that Newton left us with permanent mysteries appears to be correct. Thomas Kuhn, famous historian of science, suggests that Newton presumably wished to write a Principles of Philosophy like Descartes, meaning true science. But his inability to explain gravity forced him to restrict his subject to what he called the mathematical principles of natural philosophy, which did not even pretend to explain why the universe runs as it does, leaving the question in obscurity, permanent obscurity, Hume conjectured. Some of the ablest scientists of the 18th century continued to seek a mechanical, corpuscular explanation of gravity, that is, what they took to be a physical explanation, as indeed Newton did himself to the end of his life. In later years, positivists reproached all sides of the debate, quoting, for their foolishness in clothing the mathematical formalism of physical theory with the gay garment of a physical interpretation, a concept that had lost substantive meaning. That's Heinrich Hertz. As the impact of Newton's discoveries was slowly absorbed, science simply lowered its goals in a manner that's now so routine that it's unacknowledged. Scientists abandoned the animating idea of the early scientific revolution, namely that the world is in principle intelligible to us, and they restricted their goals to construction of theories that are intelligible. Now, that's a very significant step in intellectual history, by now so standard that it's not noticed. By the time we reach Bertrand Russell, his analysis of matter in 1927, he dismisses the very idea of an intelligible world as an absurdity, and in fact he repeatedly places the word intelligible in quotes to highlight the absurdity of the quest. Qualms about action at a distance, he writes, were little more than a prejudice. If the world consisted of billiard balls, it would be what we call intelligible. That is, it would not surprise us sufficiently so as to make us realize that we do not understand it. In this last phrase, Newton is invoking one of the great intellectual contributions of modern science, namely the ability to be surprised by what seems superficially obvious, and hence to recognize that we do not understand it. It's quite a difficult step to take. In fact, for 2,000 years, scientists were mostly satisfied that apples fall to the ground and steam rises to the heavens because they're seeking their natural place. It's only when Galileo and others were willing to be puzzled by the simplest phenomena of nature that modern science began. From a different perspective, when he moved from physics to psychology, Wolfgang Köhler observed that in psychology, it's far harder to make exciting discoveries. In physics, even the most elementary discoveries are exciting because they run so counter to common sense. For example, Galileo's demonstration, which in fact was by a thought experiment, like most of his experiments, his demonstration that rate of fall is independent of mass, contrary to what common sense would indicate. But in psychology, Köhler pointed out, discoveries seem routine, as if we always knew that, or at least we believed we did. Even far-reaching insights seem unsurprising, or to some incoherent. For example, the observation of Descartes that we can freely express our thoughts in novel ways without limit. So we speak effortlessly all the time, so what can be problematic? Some modern thinkers, like Wittgenstein, dismiss the very effort at explanation of such matters as a childish error that should be overcome in favor of what he called compiling an assembly of particulars, just collecting data. Anything beyond that is a childish error. Similarly, how can there be anything puzzling about acquisition of language? After all, it's done routinely by infants, so it must be straightforward. And efforts to deal with it should appeal to nothing beyond pointing, ostension, and training. Those are Wittgenstein's two principles of language acquisition, or perhaps to conditioning, as W.V. Quine insisted. Some went on to invoke analogy and induction when paying attention, which is rare, to the truisms that were at the core of Cartesian philosophy, but these notions remained completely mystical and still do. Outside of narrow domains, such limits on curiosity have been standard practice for the 2,500 years of extensive study of language. They persisted almost without question into the 1950s. They're still largely prevalent today. And in such ways, inquiry into language and other mental processes was stifled at birth, much in the same way that the natural sciences were curtailed before puzzlement about simple phenomena became the norm in the early scientific revolution. Historians of science have recognized that Newton's reluctant intellectual moves set forth a new view of science in which the goal is not to seek ultimate explanations, but to find the best theoretical account we can of the phenomena of experience and experiment. These more limited goals were not entirely new. They have roots in an earlier scientific tradition that had abandoned the search for what were called the first springs of natural motions, their actual causes, and of other natural phenomena, keeping to the more modest effort to develop the best theoretical account that we can. This more modest project is what historian of philosophy Richard Popkin calls the constructive skepticism, formulated in detail by Mersenne and Gassendi, later by Hume, and what he called his mitigated skepticism. Skepticism because we can never be sure to know the answers, and mitigated because we could at least go some of the direction, some steps towards answering them. This mitigated skepticism, according to that, science proceeds by, still quoting Popkin, by doubting our abilities to find grounds for our knowledge while accepting and increasing the knowledge itself, and recognizing that the secrets of nature, of things in themselves, are forever hidden from us. That's the science without metaphysics, he says, which was to have a great history in more recent times. The goal is now sometimes called induction to the best explanation, but that remains a mysterious notion which has to be spelled out and explained somehow. It's an important topic of cognitive science in principle, not one that's been investigated, but in principle it is. It still remains at best at the margins of inquiry. Well, a curious feature of contemporary intellectual culture is that anti-foundationalism is regarded as a courageous battle cry. It's curious because foundationalism was almost entirely dismissed in the 17th century, and later, once Newton's discoveries made the transition from the absurdity that he believed them to be to scientific common sense, which is now sharply divorced from our common sense understanding. Well, Descartes, too, before Newton, had recognized the limits of cognitive reach. If you look at the Reguli, Rule 8 reads, "If in the course of subjects to be examined, we come to a subject of which our intellect cannot gain a good enough intuition, we must stop there, and we must not examine the other matters that follow, and must refrain from futile toil, from speculation based on nothing." Descartes speculated that the workings of the mind, of his res cogitans, might lie beyond human understanding. As he put it, we might not have intelligence enough to understand the workings of mind. But if the explanation for the normal use of language and other forms of free and coherent choice of action, if such explanation lies beyond our cognitive grasp, that should give no warrant for questioning the authenticity of our experience. He went on to say that there is nothing we comprehend more evidently and more perfectly than our ability to choose our course of thought and action, and it would be absurd to doubt that something that we comprehend intimately and experience within ourselves, and namely that the free actions of people are undetermined, it would be absurd to doubt that merely because it conflicts with something else which we know to be in its nature incomprehensible to us. Well, for Descartes, what was incomprehensible to us is divine preordination. For a tradition from Hume to Russell, it's the mysteries that lie beyond cognitive reach of this particular organism, ourselves, with its own scope and limits. That there are mysteries of this kind should be, again, the merest truism, assuming that we're part of nature. A separate matter, and an interesting one, is how these mysteries relate to questions that we might like to answer, or that we might like even to pose in proper terms. That's, in principle, a topic subject to empirical inquiry. So it might turn out that what we call science, human science, is a chance convergence between aspects of the truth of the world and our cognitive reach, biological property of humans. That's a conclusion that might be established, for example, by some differently organized alien intelligence, just as we can reach similar conclusions about insects. And there is, furthermore, no contradiction in supposing that even within the limits of our cognitive capacities, we might in principle discover a good deal about what these limits are. So, for example, within our cognitive limits, Newtonian science did provide evidence that intelligibility of the world is in a crucial sense beyond our cognitive grasp. And if it were someday shown that intelligibility of theoretical explanation for humans is restricted to determinacy and randomness, it might be possible to provide empirical justification for Cartesian speculations about our inability to comprehend what we know to be our noblest property, our capacity for free choice of coherent action, and in fact the core of our existence. One philosopher-scientist to have tried to address these problems seriously was David Hume, who's misleadingly described as the arch-empiricist. He was very far from that. Pursuing his mitigated skepticism, Hume recognized that much of animal and human knowledge must, as he put it, derive from the original hand of nature, which provides scope and limits to what can be attained. The original hand of nature is what we would call genetic endowment, and he argues that that provides the means for the experimental reasoning that guides scientific inquiry in some obscure fashion, and also the experimental reasoning on which the whole conduct of life depends. It can be nothing but a species of instinct or mechanical power, he said, that acts in us unknown to ourselves, and in its chief operations is not directed by any such relations or comparisons of ideas as are the proper objects of our intellectual faculties. In other words, whatever it is lies beyond our intellectual faculties. In our terms, rephrasing this, the genetic endowment and its cognitive manifestations lie far beyond the level of accessibility to consciousness. That's an idea, incidentally, which is dismissed as an absurdity by leading contemporary philosophers who regard themselves, curiously, as firmly within the modern scientific tradition. In reality, the doctrine of accessibility to consciousness is sheer dogma, borrowed uncritically from long-abandoned tradition and amply refuted by empirical evidence, but quite prevalent in contemporary philosophy. Hume's ideas were taken up in different terms by Charles Sanders Peirce a century ago. He's best known for other work, but in an essay which is barely known on what he called abduction, which long remained in obscurity, in that essay, Peirce faced Plato's problem squarely. It's unusual. He recognized that attaining theories requires some principle rooted in our nature, which, as he put it, puts a limit on admissible hypotheses, a very narrow limit, if the experimental reasoning and the whole conduct of life are to be feasible. Peirce could not spell out this principle of abduction, and there's been very little progress in doing so since, beyond quite specific domains. Peirce believed that whatever it is, this human capacity for abduction is a reliable guide to grasping the truth of the world. He gave an argument based on natural selection, which he said must have favored organisms capable of this achievement, but that surely is a fallacy. No selectional process made it possible for Galileo and his successors to be puzzled by what seemed obvious for 2,000 years and to construct theoretical explanations that may or may not approach the truth of the world, which we instinctively believe to exist, even by those who hotly deny it. We cannot avoid being naive realists, Russell observed, any more than we can keep ourselves from perceiving the moon illusion. The great figures of the 17th century speculated about the mysteries of nature in ways that have a resonance today, even though we don't use their terms. So Newton, for example, thought that some unknown force, which he called spirit, may be the cause of all movement in nature, including the power of moving our body by our thoughts and the same power in other living creatures, though how this is done and by what laws we do not know. We cannot say, he said, that all nature is not alive. Going beyond Newton, Locke concluded that we cannot say that matter does not think. As he put it in his theological framework, just as God had added inconceivable effects to motion, so he might have superadded to matter a faculty of thinking. But we cannot reject it on that grounds. He said it's true that this idea that God might have superadded, he might have created thinking matter, that's repugnant to the idea of senseless matter, but we cannot reject it on these grounds given our incurable ignorance and the limits of our cognitive capacities, what he called our ideas. So having no intelligible concept of matter or body or physical, we cannot dismiss the possibility of living or thinking matter, particularly after Newton had undermined common sense understanding. Well, Locke's repugnant idea of thinking matter was developed extensively through the 18th century, leading finally to the important work of scientist, philosopher Joseph Priestley, who, like Locke and others, recognized that the traditional mind-body problem had become unformulable with Newton's demolition of the only coherent notion of body or physical or material. So for Priestley and others, the only plausible conclusion, quoting him, was that properties termed mental reduce somehow to the organical structure of the brain. Similar conclusions were drawn from Hume to Darwin. Darwin asked rhetorically, why is thought, being a secretion of the brain, more wonderful than matter, than gravity, a property of matter? Today, curiously, it's widely held among philosophers that there's a crucial explanatory gap, as it's called, between the physical and consciousness. That is, a gap beyond the concerns for a unification of science that arise throughout efforts to understand the world as somehow a more fundamental gap. However, unless the notion physical is given some new post-Newtonian sense, which has not been done or even attempted, unless that's done, there's even less reason to have qualms about an explanatory gap than in cases where there is some clear sense to the assumed reduction base. The most extreme of these concerns, and perhaps the most significant for the subsequent development of the sciences, is the explanatory gap that Newton unearthed and left unresolved, perhaps a permanent mystery for humans, as David Hume conjectured. Well, there are other curious aspects of contemporary debate about Plato's problem. Evidently, growth and development in any domain involve three factors: genetic endowment, external data, and laws of nature. For language, the first factor, genetic endowment, is sometimes called universal grammar, UG, in contemporary work. It's adapting a traditional term to a new usage. That UG exists can hardly be doubted. I mean, otherwise it would simply be a miracle that every child acquires language while its pet kitten or chimp or songbird or whatever, exposed to exactly the same data. It cannot even take the first step at determining which aspects of the data are related to language. That's no trivial task, incidentally, let alone all the rest. Nevertheless, a debate has raged over this matter for decades, a very odd debate, if only because it's one-sided. There are innumerable condemnations of what critics call the innateness hypothesis, apparently referring to the truism that UG exists. There are no defenders of the hypothesis, just as there are no defenders of the hypothesis that the mammalian visual system has a genetic component. The only serious question, as in the case of every other subsystem of the organism, is what are the properties of UG and how do they interact with other factors in growth and development. Another common objection is that little is known about the neural circuitry that's involved in the language faculty, either in its initial state before experience as determined by UG, or in the mature state that it assumes. That too is rather odd. Little is known about far simpler questions. For example, the neurophysiology of the remarkable navigational capacities and communication systems of insects. But that's never been considered a reason to question the research that seeks to determine their properties abstractly, properties which, as in the case of language, provide a kind of a guide to inquiry into what Priestley called the organical structure of the brain that underlies these properties. One prominent cognitive neuroscientist, C.R. Gallistel, has an important recent book in which he argues that throughout the long history of inquiry, neurophysiologists, psychologists, computational linguists, and philosophers have been looking in the wrong place. They've been studying associative bonds and synaptic conductance, and that, he writes, cannot encode facts about the state of the experienced world, memory storage, or the stable systems that are called upon in performance. Instead, he says, they've got to throw out the whole traditional enterprise, begin again, start looking for elementary units of computation with the properties that enter into any kind of computational system, units that have the property of read, write, and address, elementary properties of any computational system, and these, he argues, are quite appropriate to the tasks at hand, even for insects, and very likely for humans too, but are not the things that neurophysiologists are looking for. They're just looking in the wrong place. The science has to be completely reconstructed if he's correct, which he may be. Descartes' problem is beyond human inquiry, perhaps forever. We can at least try to discover the mechanisms that are used in free choice of action, including his prime example, creative use of language. That is, we can try to discover the finite means that enter into infinite use in Humboldt's formula. By the mid-20th century, the general mathematical theory of such mechanisms was quite well understood, and it can be adapted to language, where by language here I mean an internal system, a subsystem that interacts with other systems in the life of the organism, what biologists sometimes call modules or organs. Each language must be based on a finitely specified computational procedure that generates an infinite range of hierarchically structured expressions that provide instructions for two language external systems, the sensory motor system, which we use to make the noises that we hear and produce, and the systems of thought and action. So putting it in different terms, the computational procedure provides information for the phonetic interface and the semantic pragmatic interface, all parts of our body. In that way, a language will satisfy the conditions formulated by Aristotle, who described language as sound with meaning. Actually, recent work suggests that the formulation should be changed, that language is meaning with sound. That's a significant difference. According to that view, externalization of language by the sensory motor system is a secondary process, both from an evolutionary perspective and the perspective of the structural design of the system. I can't go into details here, but the basic thrust of the argument is fairly straightforward. The internal computational procedure is sometimes called a generative grammar, or more perspicuously, an internal language. It's incorporated somehow in any such procedure is an operation, call it merge, that takes two objects already generated and forms from them a new object. The simplest operation will leave the two objects unchanged and unordered, so we can take the new object to be just the set of the other two. Reapplying merge over and over again, we obtain an infinity of hierarchically structured expressions. Furthermore, if no special stipulations are added, merge will form structures with what are called displaced elements. So, for example, if merge is applied to the structure underlying John saw what, it will form what John saw what. And if we carry out merge again, it can form guess what John saw what. That structure is then transferred to the two interfaces. Well, it turns out to be just what is required for the semantic pragmatic interface, where the element what has two functions. It's the direct object of the word see, and it gets its semantic interpretation from that, and it's an operator ranging over the whole expression, which means something like guess for which thing X John saw the thing X. The X is interpreted twice. That's the right information for the semantic pragmatic interpretation, but it's completely the wrong information for the phonetic interface. So we do not say guess what John saw what. Rather, we say guess what John saw. We delete the second occurrence of John, the lower occurrence in a hierarchy. Only the most hierarchically prominent occurrence remains in externalization. The others are all deleted. And in more complex expressions, that means lots of deletion. Well, that makes sense from the point of view of efficiency of computation and articulation. They are greatly simplified by this procedure. However, it raises problems for communication. It's necessary for the hearer to determine what's missing and where it is. And that becomes an extremely complex problem, as anyone knows who's worked on automatic parsing programs or on perceptual models. Well, what this illustrates is that there's a conflict between computational efficiency and communicative efficiency. And in this and every similar case of conflict that's known, language design favors computational efficiency and sacrifices communicative efficiency. In other words, considerations of computational efficiency yield the right results at the semantic pragmatic interface for thought and action, but they harm communication. Well, that's an important conclusion. And in fact, the outcome is exactly what we would expect on evolutionary grounds. So merge is in fact clearly a universal property of the human mind brain today, but our early ancestors lacked that property. Hence, at some point in the past, not the very remote past, some mutation must have taken place, perhaps very slight, which rewired the brain to yield this capacity, to yield this operation, merge. Well, mutations take place in an individual, not in a group. And the person who underwent this mutation could exploit existing conceptual capacities to think, to interpret, to plan over an unbounded range. The person had what's sometimes called a language of thought. Well, that presumably confers a selectional advantage. In part, it would be inherited by offspring. Sometime later, the property would be shared by enough people in a small breeding group, and we come from very small groups, maybe a few thousand individuals. The property could take over a small group. At that point, if enough people have the capacity, it would be advantageous to externalize the inner thought. To do so, it's necessary to solve a hard cognitive problem, that is, to relate the internal generative system, which had emerged suddenly, to the sensory motor system, which had been around for hundreds of thousands of years. We know that from fossil evidence. So we would expect then that this secondary system, this secondary component of language, the externalization, would be complex, varied, subject to historical change, and so on. And that's indeed what we find overwhelmingly. The fact is very familiar from language acquisition. To learn a second language, one has to acquire the vocabulary, which is an arbitrary linkage of sound and meaning. You have to acquire inflectional systems. You have to learn about linear order, and so on. But no one can learn the syntactic or semantic rules, or for that matter, even the meanings of words in their normal, rich complexity, because evidence for that is virtually non-existent. In many cases, totally non-existent. And no one can teach any of this, since our knowledge of them is beyond the reach of consciousness. And what theoretical understanding has been attained is surely not put to use in language acquisition. Notice that an unbounded generative procedure is an all or nothing affair. You either have it or you don't have it. There are no intermediate stages. Well, it's commonly argued, in fact almost universally, that there must have been preliminary stages, as sometimes called proto-language. There's no empirical evidence that any such stages ever existed, and there's no conceptual reason to suppose that they did. If they did exist by some chance, they were irrelevant. It's just as hard to move from 7 to unbounded as from 1 to unbounded. So in the absence of empirical evidence or conceptual justification, a normal scientific practice would lead us to assume that there are no intermediate stages. That virtual truism seems problematic or even outlandish to almost all researchers, another curiosity. They're accustomed to think of evolution as a series of gradual steps, which it certainly is not. No serious biologist can believe that. But it's a kind of what's sometimes called pop Darwinism, popular version of Darwinism, totally not evolutionary theory, but standardly believed, even by some scientists, amazingly. The truism is often condemned as catastrophism, based on vague ideas like mutation. But those objections are entirely without merit. They actually come from scientists. The catastrophism is a conceptual necessity. There's no way to go from finite to infinite except by what's called catastrophism. You can't go in small steps. And it's not in the least inconsistent with evolutionary theory, within which, of course, mutation is a core principle. Well, notice that design considerations and evolutionary considerations converge. They yield the same conclusion, that language is designed for computational efficiency, yielding a language of thought, but it's not very good for communication. it's inefficient for communication. The conclusion was expressed lucidly by Nobel laureate François Jacob. He observed that the role of language as a communication system between individuals would have come about only secondarily, as linguists believe, I think he's referring to me. The quality of language that makes it unique does not seem to be so much its role in communicating directives for action or other features of animal communication, but rather its role in symbolizing, in evoking cognitive images, in molding our notion of reality, and yielding our capacity for thought and planning through its unique property of allowing infinite combinations of symbols and therefore mental creation of possible worlds. Those, I think, are accurate ideas which actually trace back to the 17th century cognitive revolution and have been richly elaborated in the past half century. Well, that seems surprising to a lot of people, virtually everyone who works in the field, but it's pretty straightforward, and I assume sooner or later will be understood to be pretty close to truism. Well, to summarize so far, Plato's problem falls within those parts of biology that at least we know how to study. And in some domains, including language, there has been real progress in recent years. Though Descartes' problem remains beyond reach, there has been considerable progress in, find what I'm talking about. There has been considerable progress in at least discovering the mechanisms that enter into the infinite use of the finite means, the problem that plays such a central role in Cartesian thought, and yield some consequences that depart quite sharply from common assumptions, like the ones I've mentioned. Well, let me turn finally to Orwell's problem. Illustrations abound. Even giving examples is misleading because they're everywhere, they're ubiquitous. And they give a good deal of insight into the prevailing intellectual cultures. And it's not hard to identify the means that have been developed by systems of power to ensure that people will know and understand little despite the wealth of information available to them. Well, again, I can only give scattered illustrations, and they're inevitably misleading because they may appear to be exceptional, although in fact the practices are ubiquitous. So take just one case, a recent and illuminating one, the NATO bombing of Serbia. It was the subject of an inquiry by prestigious specialists in international law, led by the eminent South African jurist Richard Goldstone. The panel determined that the bombing was, in their phrase, illegal but legitimate. The illegality was transparent. It was a flagrant violation of the UN Charter, the foundation of modern international law. In fact, it was an example of what the Nuremberg Tribunal determined to be the supreme international crime, differing from other war crimes because it encompasses all the evil that follows. That was the crime for which the Nazis were hanged at Nuremberg. And this is it's a kind of a test example, a standard example of it. Nevertheless, the panel found this war crime to be legitimate because, as they put it, there was no other way to stop the killings and atrocities in Kosovo. It should be noted that this is a standard interpretation in the West. It's a Western interpretation, accepted almost without exception in the West. The non-aligned countries, which represent the majority of the world, bitterly rejected it, condemned the bombing, and what they called the so-called right of humanitarian intervention on which it was based. They regarded it as just more of the posturing of Western imperialism with its civilizing missions and other familiar affectations of benevolence. More revealing than that is the question of fact, which is actually uncontroversial in this case. To reach its conclusion that there was no other way to stop the killings and atrocities in Kosovo, the panel had to reverse the chronology and to reject the unanimous conclusions of a mass of impeccable Western studies, including 2 detailed State Department reviews and reports of NATO, the OECD, the Western monitors on the ground, and others. The evidence reveals unambiguously that the killings and atrocities were overwhelmingly the consequence of the bombing, not the cause, and in fact its anticipated consequence. NATO, the commanding general, Wesley Clark, he informed the press as the bombing began that atrocities on the ground were predictable. He had already briefed the White House with the same prediction. Actually, the facts are revealed as well in the indictment of Milosevic, which was issued right in the midst of the bombing. The charges, if you look, are all post-bombing, with one exception, which we know meant absolutely nothing to the attackers, because at that very moment they were supporting comparable atrocities carried out by their allies in cases where the past record was far more grotesque than anything that had happened in the Balkans. And furthermore, they continued to support those atrocities well after the bombing of Serbia ended. Well, this is only a fraction of the story. What's relevant here is that the fallacious conclusion of the Goldstone panel is almost universally accepted in Western intellectual culture, in complete disregard of the unusually rich documentary record. There could hardly be a clearer illustration of Orwell's problem. And as history and familiarity with cultural norms would suggest, a rational discussion of this matter is virtually impossible in the West. Any mention of these uncontroversial facts elicits the most impressive tantrums. And that's understandable. The period before the bombing was marked by one of the most extraordinary episodes of self-glorification in intellectual history. Can't think of anything like it. Prominent figures in the West lauded themselves and their own states for acting on principles and values for the first time in history, as the attackers led the enlightened states to a new era of history, acting out of pure altruism in a noble phase of their foreign policy with a saintly glow and so on, in a deluge that would have impressed Kim Il-sung. And after that performance, recognition of the elementary facts of the matter would be a psychological impossibility for the educated classes. And they have therefore resorted to what comes naturally to them, familiar means of to protect themselves from exposure and unwanted facts, slanders, lies, hysteria, denunciation, all of them virtually unanswerable, given the near monopoly of control over expression. In this case, it even includes the dissident fringes in the mainstream, which had been in the lead, if you look back, in trumpeting their own magnificence and supporting the attack. There's a great deal in print about all this, but it's irrelevant. It's far too inconsistent with doctrinal orthodoxy and with self-protection to enter awareness. Well, the example is perhaps unusual in its clarity, but apart from that, it's pretty close to the norm. The mechanisms that are adopted to implement Orwell's problem are also not obscure. I mean, on the contrary, they've been described, frankly and with approval, by the leading practitioners and the most respected ones. Well, in brief, by World War I, elite circles in the West, primarily England and the United States, the more free societies, elite circles were coming to understand that popular struggles had achieved so much success that the population could no longer be easily controlled by force, and it would therefore be necessary to control attitudes and beliefs. among other devices, a huge industry was created to fulfill this task. It's called the public relations industry, primarily a U.S., secondarily British invention, later taken over elsewhere. There's an early industry manual by one of its leading figures, Edward Bernays. It opens by observing that the conscious and intelligent manipulation of the organized habits and opinions of the masses is an important element in democratic society. But clearly it is the intelligent minorities which need to make use of propaganda continuously and systematically, because only they understand the mental processes and the social patterns of the masses and are therefore in a position to pull the wires which control the public mind, which they can regiment every bit as much as an army regiments the bodies of its soldiers. This process of what he called engineering consent is the very essence of the democratic process. Bernays wrote 20 years later, when he was being honored by the American Psychological Association in 1949 for the quite impressive achievements that he had made. Bernays was not on the right wing. He was a good Roosevelt liberal, Wilson, Roosevelt, Kennedy liberal. In fact, he had honed his skills in Woodrow Wilson's Committee on Public Information. The name should give it away. It's the first U.S. state propaganda agency. The committee was the official component of a campaign in which the most respected liberal intellectuals undertook, in their words, to serve as the faithful and helpful interpreters of what seems to be one of the greatest enterprises ever undertaken by an American president. They were referring to Woodrow Wilson's decision to enter the European war right after he was elected on the promise of peace without victory, not entering the war. So that was one of the greatest enterprises ever undertaken by a president, and the liberal intellectuals had to serve in that cause. Unwittingly, they were serving as instruments of the British Ministry of Information, which secretly defined its task as to direct the thoughts of most of the world, but particularly the thoughts of American intellectuals. The British recognized that that would be necessary to bring the United States into the war. The targets of British propaganda, namely the liberal American intellectuals, they were adopting good Wilsonian doctrine. Wilson's own view was that an elite of gentlemen with elevated ideals is necessary to preserve stability and righteousness. It's the intelligent minority of responsible men who must control decision-making. Another veteran of the Committee on Public Information explained in his quite influential progressive essays on democracy in the same years, as they were called. That's Walter Lippmann, the leading American public intellectual of the 20th century, also a Wilson, Roosevelt liberal. This specialized class of public men is responsible for the formation of a sound public opinion, I'm quoting Lippmann, as well as for setting policy. The public must be put in its place. Its function in a democracy is to be spectators of action, not participants. It may act, but only by aligning itself as the partisan of someone in a position to act executively in periodic exercises called elections. That's the liberal end of intellectual thought. And the liberal academic world agreed. Harold Lasswell, one of the founders of modern political science, also liberal intellectual, he explained that the intelligent few must recognize the ignorance and stupidity of the masses who have to be controlled for their own good. Well, I've been sampling only from the progressive end of the spectrum. Views become harsher as we move towards the so-called conservative or reactionary end. And others were impressed by the success of these enterprises to control the public mind. Nazi propaganda, for example, consciously based itself on American commercial advertising with unfortunate success. The Bolsheviks tried to do so as well, but much more clumsily. It was never particularly successful. The basic principles remain. They take various forms, although of course they're constantly denied with rhetorical flights about dedication to democracy. Well, unlike the other two problems, Plato's and Descartes', Orwell's problem is quite easily solved at the intellectual level, but the solution to the problem explains why it remains with little impact